This is Britt Caswell with another example video. In this video, I'm covering example 5 from section 3-1 from the SavvasRealize Algebra 2 textbook. And so what we're going to be doing is interpreting some polynomial models. So how are we using some of these polynomials to find some real-world situations? So in this first part of the example, there's a girl named Abby, and she's in science class. And she's mixing a fixed amount of baking soda, so every single time she does this, it's the same amount of baking soda, with different amounts of vinegar in a bottle, and then she caps it with a balloon. So she's recording the amount of time that it takes for the gases that are produced by the reaction to inflate the balloon. So she does this, and she puts the numbers into the table, or into the computer, and the computer spits out this equation for her. And it says this is how many seconds it takes to inflate the balloon, where x is the number of quarter cups of vinegar. So part A says how long will it take to inflate the balloon with 5 quarter cups of vinegar. So all that they're asking us to do is to evaluate this expression with 5, all right? Now, when you guys go to do this, I would just use like Desmos or something to actually get the number. Otherwise, these numbers are so small that you could get very easily sidetracked with your values. Okay, so like when I was in school, I wasn't allowed to use a graphing calculator, so I had to calculate each of these by part and then add them. But if you have access to Desmos, just type it into Desmos. And when I did that, I got 6.26. So it would take 6.26 seconds to fill the balloon with 5 quarter cups of vinegar. So then part B, it's saying what do the x and y intercepts of the graph mean in this context? Alright, so here is the y-intercept of the graph. Now remember, the x-axis is the amount of vinegar, and the y-axis is the time. So when we're considering this, we have to think about, is it possible to do something with no vinegar, or is it possible to do something with no time? So this is saying with 0 cups of vinegar, the balloon will inflate in 13.6 seconds. That makes no sense, right? Because you have to have some kind of amount of vinegar for the balloon to inflate, or the gas won't be produced. So then over here, this is saying with 6.585 cups of vinegar, quarter cups of vinegar, that says vinegar, it's just really ugly, y'all, that it takes 0 seconds for the balloon to inflate. Well, the gas has to have time to travel. Alright, so if it's happening in 0 seconds, that's instantaneous, and that's impossible. So at the extremes where the zeros are, this graph isn't going to model very well. But here, like in the middle area-ish, that's where you'll probably get a more clear and correct model. So here's another part where we're going to use this. It's with a gal named Danielle. And so she's actually talking about profit. Alright, so profit is very big for this stuff. So it says, Danielle is engineering a new brand of shoes. For X shoes sold in thousands, it's a big deal, a profit of blah 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 in 10,000s will be earned. So how much will be earned in profit for selling 1,000 shoes? Now, this is where I made a goof the first time I tried to do this. I'm not going to plug 1,000 into the function, because x is talking about the number of thousands of shoes. So when I go to do this, I'm actually only going to plug in 1. Because when x is 1, that represents 1,000. So all that I'm doing is I'm going into my expression, and everywhere there's a 1, or sorry, wherever there's an x, I'm plugging in a 1. So this one's easy enough to calculate by hand, because 1 to any power is 1. So this is -3 plus 4 minus 2 plus 5 plus 10. So -3 plus 4 is 1, minus 2 is -1, plus 5 is 4, plus 10 is 14. So when she sold 1,000 shoes, she got 14 of whatever unit of profit we have. Now recognize this is in 10,000s, right? So I need to take that 14 and multiply it by 10,000. So she's going to make $140,000 in profit for selling 1,000 pairs of shoes. So then this asks us what the x and y intercepts of the graph mean in this context, which is my bad. When I made this, I didn't draw the graph. So the x-intercepts for this graph are at -0.86 and 1.9. Now remember, the x is the number of shoes that are sold, right? Can you sell negative shoes? No, that makes no sense. Now, can you sell 1.9 thousand shoes? Sure, that makes sense. And so then the y-intercept here is 10. So this is talking about making 10 times 10K is $100,000 in revenue for selling 0 shoes. That also makes no sense, right? Because you have to sell shoes to make revenue. So the only intercept that actually made sense in this problem was the positive x-intercept. So there we have it. There's a little bit of a real-world usage for polynomials. Until next time.